हेलो एंड वेलकम एवरीवन। आप सभी का स्वागत है इन द डिस्कशन सीरीज ऑफ फाइनल टेस्ट सीरीज टेस्ट नंबर 2. The phase that we'll be considering is 1A and of course subject. Maybe अब तक तो आपने पहचान लिया. The subject is physics. Let us start. Let us start with section number A and let's see what is the first question of section number A. All right, laws of motion related to spring. Now what does it say? There is a block of mass and this particular block, let's try to see what does it say, is suspended through a vertical spring of spring constant K. The block is pulled down by a distance of mg by K from equilibrium position and released. That means block was already in the equilibrium position. Block पहले equilibrium position में था. Now just think in this way, don't overcomplicate. If it was in equilibrium, then mg and initial elongation, they were balancing each other. So what is the net unbalanced force? The net unbalanced force after the pull would be created by this much of elongation. So that will be K of mg upon 4K. That's the net unbalanced force divided by the mass. That of course is the acceleration. So there you go, option number 2. अगले क्वेश्चन की ओर बढ़ते हैं. Question number 2. All right, you could see there is a bullet of this much mass fired from a gun with initial velocity this much. Mass of the gun is there. Recoil velocity of the gun just after the fire. Very simple question based on conservation of linear momentum. Initial momentum of the bullet and gun as a system is 0. The final momentum of the bullet, that is mass, is 40 divided by 1000. This is in gram, so convert it into kg. और bullet की velocity कितनी है? That is 40. So that comes as the momentum of the bullet. The gun recoiling in the backward direction, it will have a negative momentum. Mass of the gun is 3. Let's say the speed of the gun is Vg. So clearly, it's a straightforward question. You solve it. Option number 3 will be the correct one. Let's go to question number 3. All right, in question number 3, we have to calculate the tension in this string as shown in the figure. Now say this is a case of a simple pulley. By simple, I mean to say that the pulley is fixed. Now, there are two strategies. One is go with the actual formal method, or other, specifically NEET aspirant, they memorize, and I also recommend you memorize the expression of tension for this situation. Like that value of tension equals to m1 m2 divided by m1 plus m2 multiplied by sine alpha plus sine beta multiplied by g. Now you see, the preparation of physics specifically for NEET, there are certain expression, अगर आप उन्हें याद करेंगे, you would always be in an advantage. तो जहाँ जहाँ expression याद करने से आपको फायदे मिलते हैं, do it. It's always better. That will save the time. Let's put the value m1 m2. So that's going to be 50, and m1 plus m2 is 15. Sine alpha, sine 37, that is 3 by 5. Sine beta, sine 53 is 4 by 5 multiplied by g, that will be taken as 10. So of course this is 50 divided by 15 multiplied by 7 by 5 multiplied by 10. Easy solution, you can solve this and that you will get as 46.67 Newton. लेकिन अगर आप कहेंगे नहीं जी, मुझे तो expression याद नहीं था, I don't remember, I need the formal technique, let me just show it. Now if I assume that this goes down with acceleration a, this will also go up with an acceleration a. After resolution of the free body diagram, that will be 10g sine 37 minus of t is equals to 10 times a. This is the tension. Likewise, this would also be the tension. तो इसके लिए equation क्या बनेगी? t minus of 5g sine 53 will be equals to 5 times acceleration. Now all you have to do is that divide equation 1 by 2 Acceleration cancel out हो जाएगा. You will be able to calculate the value of tension. Let's go for question number 4. Now in question number 4, this is the situation of friction जहाँ पर we say connected blocks, एक block के ऊपर दूसरा block. And generally this question is considered to be in the tough category. Here when you apply a force 24 Newton, now there are two possibilities. Either the blocks will move together or the blocks will move separately. पहली बात आपको ये कंफर्म करना चाहिए and then after that you have to calculate the acceleration of 2 kg block. तो ये कंफर्मेशन कैसे करें? इसके लिए तो मैं सजेस्ट करता हूँ कि आप फॉर्मूला मेमोराइज कर ही लो, क्योंकि नीड के वो प्रेशराइज मोमेंट पे you would not be able to derive all those things. Time is a big crunch in the examination hall. If the maximum force for which the two blocks move together, you see this surface is smooth, right? Here mu is 0 and for this mu is 0.2. So that is equals to mu, which is 0.2 multiplied by m1 plus m2 multiplied by g. Now let's see. This is the maximum force which will be applied on the lower block so that both will move together. Now let's first confirm. This is 60 multiplied by 0.2, that is 12 Newton. And how much is the force? The force is 24 Newton. That means the blocks will move separately. And if the blocks would move separately, the friction acting here would be kinetic. For 4 kg, kinetic friction will act backward. For 2 kg, kinetic friction will act forward. Now we need to concentrate on 2 kg block because the question asks the acceleration for 2 kg. So the force is mu multiplied by mg is equals to mass multiplied by acceleration. 2 and 2 gets cancelled. So A will be mu g, mu is 0.2 multiplied by g 10, the acceleration will be 2 meter per second square. Let's go for question number 5. There is a force and that varies with time as shown in the figure. You have to calculate the magnitude of impulse. Now what does impulse mean? Impulse indicates the change in momentum. और change in momentum को हम कैसे निकालेंगे? Let me call that as impulse will be integrate f dt within the given interval. So this will be 6 minus of 80 multiplied by dt. The limit of course from 0 to 10. I believe this simple integration you can do 60, so that will become 60 minus of 4t square. So that will be 100 into 4 is 400 and that is minus of 340. But एक शब्द पे ध्यान देना, magnitude. So magnitude means if there is a negative value, you make it positive, as simple as that, nothing more than that. So 340 Newton second will be the impulse acting on the block. Question number 6. Now let's say two blocks A and B of mass 2m and 4m, let me write it here, 2m and 4m are connected to each other by an ideal spring. The whole system initially is in equilibrium with an inextensible string. We have to calculate acceleration of A just after cutting this string. Now remember, this is again another important question. एक concept आपको ध्यान देना है कि जैसे आप string को cut करते हैं, the moment you cut the string, the tension will change immediately, but restoring force, this particular restoring force, that does not, okay, so does not change instantly. The underlying concept is this, जो restoring force है, वो instantly change नहीं हो सकता. All right, this does not require calculation. Look, okay, the tension changes, fair enough. But as far as the free body diagram of A is concerned, A gets two forces. One is the restoring force, other is mg, so m of A multiplied by g. Now see, you cut the string, इसमें तो कोई change नहीं आएगा, weight जितना है उतना ही रहेगा, और restoring force ये भी उतना ही रहेगा. Now initially the system was in equilibrium. So initially acceleration was 0, and just after cutting, the restoring force does not change, the weight is same. So the net force acting on A before and just after, that is same. So acceleration would also be same, so that is 0. Think about it. I used less mathematics to give you an idea कि physics के हर numerical में डेप्थ कैलकुलेशन इन डिटेल कैलकुलेशन करने की ज़रूरत नहीं है, जहाँ जहाँ मौका दे देता है जस्ट ट्राई टू गो इन दिस मैनर. दैट्स एन ईजी वे ऑफ सॉल्विंग. लेट्स गो टू क्वेश्चन नंबर 7. क्वेश्चन नंबर 7 क्या कहता है? द लीनियर मोमेंटम वर्सेस टाइम. सो पी वर्सेस टाइम ग्राफ हैज बीन गिवन. We have to calculate particle will be in equilibrium. Now what's the meaning of equilibrium? The meaning of equilibrium is net force is equals to 0. तो आपका एंटायर फोकस है इस ग्राफ की मदद से नेट फोर्स कैसे निकालें और वो 0 कहाँ है. You got to search that. Now all of us know that the expression of the force is dp by dt, and dp by dt means the slope of momentum time graph. कहने का मतलब आपको ग्राफ में ढूंढना है वो पॉइंट यू हैव टू सर्च वेयर द स्लोप ऑफ मोमेंटम टाइम ग्राफ इज 0. नाउ द स्लोप इज 0 हियर एट द लोकल मैक्सिमा, एट द लोकल मिनिमा. सो एट T2 and T3 द स्लोप इज 0, so the net force is 0. That means the particle is in equilibrium. Question number 8. Okay, this is good. There is a force 2I cap plus 4J cap acting, frictional force acting. Now let's see. 2I cap plus 4J cap means here is 2 Newton and here is 4 Newton. Apart from that, you also have normal reaction and there is 4G. Now from this, you could see n plus 4 is 40. That means the value of n is 36. Easy calculation. Now before you calculate friction, it's a tricky thing. पहले आपको verify करना होगा situation कैसी है. What sort of situation is there? Is it a case of static friction or is it a case of kinetic friction? तो वो पता करने के लिए let us find the limiting friction. Now limiting friction is mu s multiplied by n. Simple mu means common for both mu s as well as mu k. So mu s is 0.1, normal reaction is 36. That means the limiting friction here acting is 3.6 Newton. And how much is the applied force? Applied force is 2. क्योंकि applied force limiting force से कम है, so of course this given block is at rest. And if it is at rest, the net force has to be 0. The force acting would be static. So static friction has to be equals to 2 Newton. तो जब भी आपको फ्रिक्शन से रिलेटेड क्वेश्चन आता है, यू नीड टू पॉज, यू नीड टू थिंक. ऐसे क्वेश्चन थोड़ा सा फसाऊ टाइप के क्वेश्चन होते हैं. You got to be very, very careful with that. All right? Okay, now question number 9. What does it say? There is a system of 2 blocks, 4 kg, 2 kg और बीच में एक spring है. Now it says, when the 2 kg block has an acceleration of 4 meter per second square, I got to calculate the acceleration of 4 kg block and the surfaces are smooth. Now clearly the spring is in elongated stage और एक elongated spring में जो restoring force आता है Fr इस direction में, Fr इस direction में. Because there is a spring, so we can't say that the acceleration will be same. Let me call this as A dash. Let's see the free body diagram equation. 2 kg block के लिए equation क्या बनेगी? 12 minus Fr is mass multiplied by acceleration. So the value of Fr now comes out to be 4 Newton. Now it's very clear. The same Fr restoring force 4 Newton is acting on 4 kg. अब क्या solve करें? 4 Newton, 4 kg, the acceleration will be 1 meter per second square. Option number 3. Let's go for question number 10. All right, this may be a bit tricky one. There are 2 masses, 15 kg each. There is a spring balance. हमें निकालना है reading of the spring balance. Now, for the reading of the spring balance, you got to calculate the restoring force here. And Which force generates the restoring force? Of course, the tension. चाहे आप इधर का टेंशन निकालिए या इधर का टेंशन निकालिए, that is eventually going to be same. So let's see how much. This is T, this is 15G. यहाँ से भी आपको यही equation मिलेगी. And since the overall system is at rest, 15 kg, so the value of tension is 15G. So if you have to calculate the reading in kg, that has to be 15 kg.